Hello everyone, welcome back to this training workshop series on the Eclipse Arrowhead Framework. My name is Salman Javed and I'll be your guide through this second video where we will start by discussing the prerequisites for installing the Arrowhead Framework on an edge device such as Raspberry Pi. This will include both hardware and software requirements to ensure you are well prepared for the installation process. Then we will walk through a step-by-step guide for installing Arrowhead Framework. This will include both in detailed instructions for setting it up on edge devices as well as on the servers. The aim is to make the installation process as straightforward as possible. And then we will walk through a demo. So here is a detailed deploying the Eclipse Arrowhead Looker Cloud on Raspberry Pi installation guide. So we will go through all these 8 steps to install and to set up the local cloud on an Raspberry Pi. So let's go through them one by one. So let's start. So what I'm doing is right now we are SSHing the Raspberry Pi with the username is Javsal and the IP address is 192.168.0.100. And then the first step from the guide is to update the OS. So we use the command sudo apt update, and then we install the default Java JDK. So as you can see, I have already installed on this Raspberry Pi. So it's just check for the updates if they are available. Then we can search for the version of the Java and verify that it's installed or not by using the command java space hyphen version. So I have installed JDK 17.0.6. Then we can update the OS again and get ready to install the Maven, which is a step 3 in the instruction guide. So sudo apt install Maven is the command to do that. Once that's done, we can set the environment variables. So the commands for the setting up the environment variables is given in the instruction guide. So my Maven installation is located at user/share/Maven. So I will add that into the /bashrc file so that the environment for my terminal is set up. So this is the required step because we used Maven to install the Arrowhead local cloud. The next step is to also set up the environment variable for Java so that we can run the Java-based Arrowhead core systems. And we set up the path variable to m2_home. And the last step in setting up the variables is setting the Java variable as well. And then we can see the MVN version by using the command MVN space hyphen version. So I have installed Apache Maven 3.6.3, and it also shows that what Java version I have. So the fourth step is to install the database. So in Raspberry Pi we cannot install MySQL. So for Raspberry Pi we need MariaDB server to run the MySQL on it. So the command is sudo apt install MariaDB server, and then after installation is finished, we can use the command sudo mysql secure installation. And here we need to set up the password and for the root user. And we can just press yes for rest of the options provided by the installation process. So MariaDB is installed. So if we just write MySQL, we see that it's gives a permission error. So we need to do sudo mysql -u root -p, and then provide the password which we set up earlier. Now we are inside the MariaDB database, and we can see that if there are what are the tables, or if there are any databases installed already set up in the MySQL. So here we see that I have Arrowhead database already there. So first I will delete the database, and then I will uh, rebuild the database as again for this demo. So by dropping the database Arrowhead, it is deleted, and we can verify that with show databases command that it's no more there. Now we exit the database, and the next step is to install the Git, because we will clone uh, from the Git repository of Arrowhead Framework. So Git is installed, and then we can verify it by using the git ---- version command. So in the instruction guide, we have provided two repositories. So both of them have the Arrowhead Framework 4.5, 4.6 versions, but I'm using the Eclipse Arrowhead official Git repository. So that will download the most latest version automatically. So the command is git clone and then the address of the Git repository. So it will take a few minutes to download. It's around 1.3 GB of data to be downloaded. we can see that it's almost half done. It's almost done, about 90% of the. It shows 51% receiving objects, but usually when it's almost done by now, because the total size is around 1.13 GB. So it includes all the core systems, mandatory ones, and also the supporting core systems available. Suddenly it went to almost 100%. So now we see that it's done. It's just finishing the process. So the files are done, and now we can verify that. So we see a core Java Spring repository directory, and we see all the core systems over there. So there is a script folder over there where we have the scripts for building the database. So as we deleted the previous Arrowhead database, which I had from the previous installation, so we need to create new empty database and also the tables for that. And there are a couple of scripts in the script folder of the core Java Spring directory, where we can give this sudo mysql -u root -p command with create empty Arrowhead database SQL. We can run the script, provide the password for the MySQL database, and the Arrowhead database will be created. And then we can run the command again with create Arrowhead tables. And it will create all the tables for all the core systems. Again, we provide the password. And now we can verify that we have the database in the MySQL by going to MariaDB, and then again provide the show database sys command, where we can see that now Arrowhead is there, and we can use Arrowhead database, and then we can see all the tables by the command show tables. So as we can see, we have service interface, service systems tables, service registry, authorization, orchestration, all the tables are there. So now we are ready to do the installation of the core systems, but there is a pom.xml file in the main directory of the core Java Spring where we can specify which core systems we want to install and build. So the core common module or the core system is the main requirement, and then we are just installing a service registry, orchestration and authorization mandatory core systems, because it's gonna rest of them are supporting core systems, and for the basic Arrowhead local cloud installation we don't need them. So if we go to the Arrowhead Framework GitHub wiki, there we can see all the core systems and their specifications as well. Like this one over here in the core Java Spring Eclipse Arrowhead Framework, we can see we have all these core systems, gateway, event handler, and their detailed documentation over there. And we have the installation process also available over here for installing it on Windows, Mac, or Linux machines with the video tutorial which is available, and using the tools which are over there. But for the Raspberry Pi and Edge devices, we need to follow the process which I'm showing here. So now we are ready to install by using the command mvn clean install -d skip test, because we don't need to do the unit testing. So first it builds the core common 4.6.1. So now we are building the latest version of the Arrowhead framework, which is 4.6.1 on Raspberry Pi 4. So we see that it's pretty fast, even though Raspberry Pi 4 is a very resource constrained device, and but still it works seamlessly and very fast. Service registry is done. Now authorization core system is being installed using Maven. After this, the last one, orchestrator, is being installed. So all of them are successfully installed, and we see that there were no errors. So we can verify that by going to the service registry and to see if there is a target folder in it or not. So after installation of every core system or application system, we get this target folder where with all the classes for Java. So we see that it's there, and there is the application.properties file, which is the configuration file where we define with the MySQL parameters. So like the IP address and the port of MySQL, we see it's there. We have the service registry, IP address and its port, which is 8443 by default. And then we also have the information about the certificates, because we installed it in secure mode. And for running it in secure mode, we need the service registry.p12 certificate and trust.p12 certificate. And also we need the passwords for them, which is 1, 2, 3, 4, 5, 6. So I'll explain in a bit about the certificates as well. Then we can come out to the main repository, and we can see that if we go to the source main, and then in the resources, we have the folder for certificates. And in this folder, we provide the certificates for this course system, like for the service registry. So it loads the certificates from here. So if we just we want to clone with the same set of certificates at multiple local clouds, we can use same set of certificates, or we can have we can just change the if we have the new certificates, we can just change the certificates over here, and automatically loads from this folder while running we don't need to build the service registry again. It will automatically be loaded from here. Now we can again go to the authorization target folder. So in there, we will see the application.properties file again. And here we see that we have this again database parameters, and also we have the address, IP address, and the port number of the service registry which we are using. And then similarly, we have the certificates folder for authorization and trust store. And similarly, just like service registry, here we have this, and in the certificates folder of authorization core system, we have the authorization.p12 and truststore.p12. Now we can open a new tab, SSH again to the Raspberry Pi. Provide the password for the Javcell username, and now we are inside the Raspberry Pi. And now we firstly we will run the service registry core system. So we go inside the target folder of the service registry and run the command java -jar arrowhead service registry 4.6.1.jar, and it will start the service registry core system. So when we download and install the Arrowhead Framework local cloud core systems from the Git repository, they already have included certificates for a test cloud, which is named as test cloud 2. So they have pre-built certificates over there. So but you can generate your own certificates, which I will explain in another video how to do that, and then use those certificates by just replacing them with the already uh, provided certificates of test cloud, because that's for the testing and demo purpose only. Then so the sequence is that we need to always start the service registry core system first, and then we can start orchestrator or authorization core systems or any other core systems. After installing all these three, then we can run any other application or a supporting core system. So the sequence is very important. Without running the service registry, we cannot run any other core or application system. For the same procedure, java -jar arrowhead authorization core system, we inside the target folder of the authorization core system, and it will be started, and load the certificate from the test cloud, which was given already in the certificate folders. So it says service registry is accessible. So if service registry is not running, then it gives the error and it will not run the authorization core system as well. Now we open a third tab to run the orchestrator core system. Similarly, we go into the target folder of the orchestrator and run java -jar arrowhead orchestrator -4.6.1.jar, and it will also check for the service registry availability and then run the orchestrator core system using the test cloud 2 certificate. And we're running everything in secure mode using the provided certificates. which is testcloud2.iatia. You see, it's the same one. Test Cloud 2 is basically the cloud name, and AITIA is the operator name, and the last is the arrowhead.eu, which is has to be the same for all the Arrowhead compliant certificates. So I can show you that this test cloud certificates, how they look like. So we have the authorization, choreographer, event handler, gatekeeper, onboarding controller, QoS monitor, sysop, system registry, all these certificates available in the test cloud too. But as you can see, I have also generated certificates for factory, LTU cloud, smart home, smart_home, and test cloud 1. So using the certificate generator tool provided by the Arrowhead framework, and also we can use the key store. I'll go through. So in order to install the Arrowhead framework on the Windows machine or a Linux machine or Mac, so we can just download this in the installer and run it, and you will be able to do that. There's a detailed video tutorial for doing that available on the YouTube, and it has the complete procedure for installing on these machines. We will also talk about certificate generation a little bit over here. If you go into so this is the naming convention for the master certificate, which is provided by the Arrowhead framework, and then the cloud, we generate the cloud certificate and the client certificates. This is the naming convention we have to use, and then we can use either key store generation tool for certificate creation, or we can use Python scripts or graphical user interface, which is provided by AITIA. And that's it for this video. Thank you very much.